is Dr. V. Anitha Rani, Associate Professor of Chemistry from Institute of Aeronautical Engineering. We discussed in the natural resources about water resources and land resources, energy resources. In energy resources, we discussed about renewable resources and non-renewable energy resources. In renewable energy resources, we know what are the renewable energy resources. So that can be inexhaustible resources. So we can get renewable resources within enough span of time. So that are called renewable energy resources. So what we are going to discuss today is alternate energy resources. Means when these non-renewable energy resources, and non-renewable energy resources means coal, petroleum, natural gas. When these are not available to us, we can go for alternate energy resources. So alternate energy resources are solar energy, wind energy, geothermal energy, hydropower energy, biomass energy, tidal energy. All these are, it is called alternate energy resources. So alternate energy refers to energy sources other than fossil fuels. Fossil fuels means when coal, petroleum, diesel, it is not available to us, then we can go for alternate energy resources. So the energy sector, fossil fuel source have been the main energy source due to their relatively low price. Why we are using petrol, diesel compared to the alternate energy resources or renewable energy resources means because their low price. Okay, so our energy demand it is increasing day by day. So we have to use. We need more fuel. We are going for alternate energy resources. So our energy demand is predicted to rise in the future. So solar panels, wind turbines set, hydroelectricity are called that we are using mostly as alternate energy technologies. So that will supply enough energy for the future energy needs. Means our future generation, they can use alternate energy resources for energy production. So the three alternate energy sources with the highest percentage are hydropower accounts for, we can take here 1172 here gigawatts, and which is about half of the total amount. And we can take wind energy 564 gigawatts, and solar power will be 480 gigawatts. Okay, so that we are getting from solar for photovoltaic and solar thermal power. From that plants we are getting solar energy, electricity production from solar plant means panels. So alternate energy sources are forecast to expand in every sector by 2023. Means we are now 2021. By 2023, so here it should expand. The alternate energy resources we have to use. So here the electricity sector has the biggest share of 30% and on the path of the decarbonization. Decarbonization means when we are using fuels, petrol, or diesel, when we are using here vehicle emission, okay, from the vehicles, when we are using vehicles, we are getting the emission from the vehicles that is having more percentage of the carbon monoxide. But when we use alternate energy sources, so that effect will not be there. Okay, so electrification will become the main energy carrier, the bulk of it being generated by renewable energy. It is we are getting electrical energy we are getting by renewable energy. So our dependence on natural gas and oil is the biggest reason for environmental damage and in the energy sector alone. So when we are using the natural gas and petroleum oils, our environmental damage is taking place. Okay, so effect of the environment is taking place. Okay, so because of that, we are going for alternate energy resources. So that is responsible here, the natural gas and petroleum oils, that is increasing 1.7 percentage increase of carbon dioxide gases in our atmosphere. So alternate energy sources will be the main focus to prevent further climate change effects on our planet. So if we are using fossil fuels, natural gas, petroleum oils, we are getting, what is the emission we are getting? What we are getting? Carbon dioxide. So that leads to the global warming, that leads to the greenhouse effect. But when we are going for alternate energy resources, we are not getting this. We can protect our planet. So here the fossil fuels are the main one that is causing the damage of the environment, affecting the environment. So we are going for here alternate energy resources. For example, wind energy, solar energy, and hydropower energy. And also we are going for another here alternate energy resources like geothermal energy and tidal energy. So all these alternate energy resources we are using, and what is producing? We are producing electricity. And we are preventing. What we are preventing here? We are preventing the pollution in the environment. We can decrease the planet's pollution level year by year on year. We can decrease the pollution in the environment by using alternate energy resources instead of the fossil fuels. So the major advantage of alternate energy technology is that it won't run out. Our days using fossil fuels are numbered. How fossil fuels are formed: coal, petroleum, or natural gas. It will take a million years to form, to turn wood into coal and to turn into the petroleum. To get the natural gas, it will take million years. So that if we are using overutilization now, so our future generation, for them, there won't be any non-renewable energy resources. So our days using fossil fuels are numbered. Okay, so only number we can count how many days we can use. Okay, so any and all alternate energy resources are beneficial over traditional sources. So we have to go for alternate energy resources. So that is more benefit than fossil fuels. So another huge advantage is that many of them do not require the same damaging and expensive extraction techniques as much of it is available here on the surface. See, alternate energy resources, what we are using? Hydropower energy, we are using water. Solar energy, we are using sun. Wind energy, we are using the blow of the air. So that is available. More amount means the quantity means abundantly it is available in the environment. So we can utilize that alternate energy resources. So first, solar energy. Our sun is a natural nuclear reactor. It releases tiny packets of energy called photons, which travels the 93 million miles from the sun to earth. 93 million miles from sun to earth is about 8.5 minutes. So from the sun, so it is the sunlight, it is falling on the earth, so it is traveling 93 million miles. It is reaching about 8.5 minutes. So there are some steps are there in solar energy. The first step is sunlight activates the panels. So here each individual panel is constructed a layer of silicon cells. We can see in the diagram. The silicon cell we can see N-type silicon, P-type silicon. Okay. So when the sunlight is falling, okay, the flow of electron takes place from N-type silicon to the P-type silicon. So here we are taking silicon cells, a metal frame, and a glass casing surrounded by a special film. And here we are taking that panels, we are grouped together. We are taking a number of panels into a series. We are arranging like a series, and we are placing that panels, we are placing on the rooftops, okay, or in the outdoor spaces. means for agricultural field also we can use electricity. Okay, so near agricultural field also, outdoor spaces we can arrange the solar panels, or on the rooftops also we can arrange the solar panels. So the solar cells, which are also referred to as photovoltaic cells, absorb the sunlight during daylight hours. So during daytime, so this photovoltaic cells, it absorbs the sunlight, and it will convert into electrical energy. So within each solar cell, a thin semiconductor wafer made from two layers of silicon. One layer is positively charged and the other is negatively charged. Already I told N-type silicon and P-type silicon. Nothing but N-type silicon means negatively charged. P-type silicon means positively charged. So one layer is positively charged and the other is negatively charged, forming an electric field. So when the light energy from the sun falls, light energy from the sun strikes the photovoltaic solar cell. When it is falling on the solar cell, it energizes the cell and causes the electrons. So where will be electrons? In the atoms. Okay. So that electrons, so the loss of electrons will be taken place from the atoms. So what is N-type means? N-type, we know what we use. N-type silicon means we will use phosphorus in the silicon material. So what happens from the phosphorus atoms? So the electrons loss will be taking place from phosphorus atom. So that electron is flowing from that N-type silicon. Electron is flowing from N-type silicon to the P-type silicon. So what is P-type silicon we will take? Here we will take boron material, boron atoms, that will be in the P-type silicon. So electron flow will be, it is taking from N-type silicon to the P-type silicon. So the loss of electrons from the atoms within the semiconductor wafer. So these loses electrons are into motion, means they are moving into motion by the electric field surrounding the wafer. Okay, and this here that motion, the movement of electron, the flow of electron is nothing but production of electrical energy, production of electricity. So in the diagram we can easily observe, we can see here how the current is flowing, the flow of electrons from the P-type silicon to the N-type silicon, from P-type silicon to the N-type silicon. So this is here we can see, this is a P-type semiconductor, N-type semiconductor. So from the where electron is flowing, when the sunlight hit the photovoltaic cell, solar panel, so from N-type semiconductor, the electron is flowing to the P-type semiconductor, and production of electrical energy will be taking place. So here we are taking the bulb. We arranged a light bulb here, and you can see the solar panel where the two layers you can observe in the diagram. N-type semiconductor here, and P-type semiconductor, and here how this current is flowing from N-type semiconductor to the P-type semiconductor. Step 3 is the electrical energy is converted. Solar panels working efficiently to transform sunlight into electricity, but the electricity generated is called direct current, DC. Okay, direct current electricity, which is not the type of electricity that powers most homes, which is alternate current electricity what we are using. So fortunately that DC electricity can easily, it will change into AC electricity by a gadget called inverter. So we will arrange the inverter, we will convert into DC current, direct source current, okay, direct current into alternate current, so that we can supply to the homes. So here converted electrical powers to your homes. The solar energy has been converted from DC to AC electricity. So it runs through your electrical panel and distributed within the home to power your appliances. So your appliances means in our home only we will use the refrigerator, okay, and we can use for fans, okay, fans, lights, okay, and we can use geyser and TV, okay. So we can connect to the like refrigerator power source, okay, the power appliances, and we can use this electricity from the solar panels. Production of electricity is taking place that we can use in the home. So next we can see in the diagram. So what we discussed previously, the sunlight activate the panels, the cells produce electrical current, the electrical energy is converted, a converted electricity powers to your home, and a net meter measures usage. So we can see the how it is converted, and we are using the solar energy, okay, converted into solar, the from sunlight, okay, we are converting electrical energy by using solar panels. So in this diagram we can observe very clearly how solar panel works. How solar panel works. The sunlight hits the solar panels and generates electrical current, okay, so that is converted into AC current by inverter, and that we are using for home appliances. Next is wind energy. Okay. Wind energy is the kinetic energy associated with the movement of atmospheric air. So windmills converted wind energy into electrical energy. So we will arrange in the field. We can see in the diagram. So we arranged windmills. We arranged windmills. Okay. So the windmills convert the wind energy into electrical energy. So the efficiency of the windmill is increased with the speed of the wind. If the speed of the wind is more, we will get more electrical energy. And it depends on length of the rotor blade. And the total wind energy potential in India estimates that 25,000 megawatts. Okay. The wind energy is a source of renewable power which comes from the air, air current flowing across the Earth's surface. So wind turbines harvest this kinetic energy and convert into usable power which can provide electricity for domestic purpose and for industries and for agriculture sectors. So in the diagram we can observe the wind passes over the blades and makes them turn. So here the blades, the movement of the blades we can observe here. The blades turn a shaft within the here we can see in the box, we can see the box at the top of the turbine we can observe. Okay, turbine blade is moving. The shaft turns, the shaft is moving. The shaft turns a generator. So we will arrange here a generator. We can see in the diagram, generator we arranged here. Generator, and shaft is moving as the blades are moving, and here the turbine blades also moving, shaft is moving, and here generator we arranged. So the shaft turns a generator which converts the kinetic energy into electrical energy. So the transformer converts, we can see the transformer here. The transformer converts the electricity to the right voltage for the local network, and electricity, and we are allowing the electricity, we are passing to the home appliances. So this is now how the wind energy that will be converting into electrical energy. So wind turns the turbine blades, spinning of the shaft will be taking place, generation of electricity will by moving the shaft. Okay, generation of electricity will be taken place by generator, and inverter converts electricity from DC to AC. Okay, direct current to alternate current, and electricity is connected directly to the main power, or connected to the battery bank, or connected to the electricity grid. So in the diagram we can observe how wind energy converted into electrical energy. So next is geothermal energy. So as the name suggests, geo means earth, thermo means heat. Geo means earth and thermo means heat. Geothermal energy comes from the heat produced by the earth. So from under the earth, so there will be more heat under the earth. So we collect that heat and will convert into electrical energy. So geothermal energy found within rock formations. So beneath the surface of the earth, there are a number of heat producing layers of rock. Minerals and magma, including mantle, the outer core and the inner core. So beneath the surface of the earth, so we can see heat producing layers of the rocks. So the deeper you dig towards the center of the earth, the hotter it gets. The deeper we are digging the center of the earth, the hotter we get. So that heat will collect and will convert into electrical energy. So geysers, a natural spring that emits hot water, and hot springs are examples for geothermal energy, where the steam and hot water comes to the surface in areas where the steam is tapped by drilling, and obtained steam is then used to generate power. So we will use the steam, that steam we will use and will convert into electrical energy. So we can see in the diagram, so the geyser we can see the springs, spring water, okay, that is very hot water will collect and will convert into, so from that will produce steam, from that steam will produce the electrical energy. So geothermal power plants also, here already we discussed this, we are collecting the hot water and producing the steam. So the core, about 4,000 miles beneath the surface, when we go deep into the earth, 4,000 miles beneath the surface, can reach the temperature 4,200 degrees centigrade. 4,200 degrees centigrade temperature will be there when we are going into the 4,000 miles beneath the surface. So the temperature gradient in earth anatomy can be used for the production of electricity. So that much deep we are going and we are collecting the heat and we are producing electricity. So this heat which can be harnessed for energy is caused by residual heat from the formation of the earth, as well as decay of radioactive isotopes. How much heat, how that very we can see the temperature 4,200 degrees centigrade, how it will be under the earth, that much temperature means because of the that heat which can be harnessed for energy is caused by residual heat from the formation of the earth, during the formation of the earth, as well as decay of radioactive isotope. So because of the decay of radioactive isotopes, so we are getting that much heat under the surface by the decay of radioactive isotopes. So in the diagram we can clearly we can understand. So hot rock beneath the means under the earth, impermeable rocks are there. So we are collecting geothermal water. Geothermal water we are collecting. We are digging one pump here and we are collecting water. So from that water we are utilizing, we are producing the steam and we are generating electricity. So how working of geothermal power plant? So we can observe in this diagram, we have collected hot water and we produced steam, and that steam we are passing into the generator where movement of turbine blades we can observe, and that conversion of electrical energy is taken place in generator and we are passing to the home appliances. Okay, we'll pass to the transformer. From there we are passing into the for domestic needs and industrial needs, and that cooled water after steaming, after converting, so then again we are passing that water again into the earth. We are passing again, we are inserting one more pipe, we are arranging. So we are arranging cooling tower here, we can observe in the diagram, and from that pipe we are collecting again cooling water and we are sending that water into the under the earth. So hydroelectric energy, we discussed about geothermal power plant, working of geothermal power plant. So how we are generating electrical energy from geothermal energy, nothing but the hot water which we are collecting from the under the earth. Now next, hydroelectric energy. So the electrical power is generated by hydroelectric projects in which dams are constructed across the river. So we know different dams are there in our state, okay, in our country. So why we are constructing the dams means we will reserve the water, we will store the water, we will use that water for production of electrical energy. We will give that water, we will um, for production of the means for the growth of the crop. Okay, for agricultural field we give the water. So the kinetic energy of water is converted into mechanical energy by means of turbines, and in turn the mechanical energy is transformed into electrical energy by generators. So same principle like previous we will follow here also. We will take the water and we will allow into the turbines. So where the movement of turbines will be taking place, where mechanical energy converted into electrical energy. So where we arrange the generators. So after converting into electrical energy, we will use that. So hydroelectric power or hydroelectricity is basically electrical energy that has been generated using natural source. Here what we are using, water. So it is produced by dams because we can store the water here. So we can see in this diagram, so where we can see the dam here. So we stored water. So we are passing the water from the dam, where we arranged here turbine blades. So the movement of turbine blades is taking place. So we arranged a generator where mechanical energy will be converted into electrical energy. So we arranged a transformer. Okay. So from the transformer we are supplying current. We are supplying electrical energy to power lines. So powerhouse is there. We can see powerhouse. So from that powerhouse we are passing the current to the power lines. So dams can generate electricity because they can contain a special mechanism designed to take the energy in flowing water and turn into electrical power. So the power source is used to spin the turbine, basically a propeller, which in turn spins the metal shaft, and here it is converting into electrical, converting into electricity by here arranging the electrical generator, which produces, converting into electricity. So the power source in case of hydropower is water itself. So here when water moves turbine, the turbine spins and electromagnets in the turbine generates electrical current in the stationary coils of wire inside them. So because of this movement of turbines, where we can convert here from the water, we can produce electrical energy. So the power system, hydroelectric power system working of, we can observe in the diagram clearly. Okay, we are flowing the water through turbines where the movement of turbine is taking place. So the electrical energy is produced in the generator, so that we are passing into the transformer and we are using the electricity. So next is biomass energy. So biomass is a renewable energy because it contains the energy which comes from the sun. It contains the energy which comes from the sun. So biomass is basically an organic material made from plants and animals. Okay, where we are getting biomass, we are getting from organic materials, that is from plants and animals. From plants and animals. So through the process of photosynthesis, chlorophyll present in the plants absorbs the energy from the sun by converting the carbon dioxide present in the air and water, in the presence of air, in the presence of water, and in the presence of carbon dioxide in the air. Okay, it will convert into carbohydrates. So the plants, that is containing chlorophyll, it absorbs the energy from the sun. So by converting the carbon dioxide present in the air and water from the ground into carbohydrates. So this process is called photosynthesis. So when these plants decay of the plants, the same energy after the decay of plants, the same energy is released into the air. So they captured from the sun. So when these plants and animals are burnt, so they turn back into carbon dioxide and water. And release the captured sun's energy. Again, that energy is released into the atmosphere. So in this way, we can say that Biomass is a renewable source of energy because we can always produce more crops and plants, and waste will always exist. Means once a plant decay or plant burning, again we will go for growth of the plant, growth of the crops. So again that plants again decay or burning. So it is the like always it is going like it is like a cycling process. So it is called a renewable energy. So as long as biomass is produced, means the organic material we are getting from the plants and animals, as long as biomass is produced, so this source of renewable energy will last forever. We can use always biomass energy. Examples of biomass includes plants, crop residues, wood chips, corn, and some type of garbage. So garbage means we can take food waste. Plants, crop residues, wood chips, corn, and some type of the garbage. All these are called biomass. So biomass itself, it means that what we are taking, the either plant or garbage, that is containing chemical energy. That is containing chemical energy. So when you burn wood, when we are burning the wood, which is a biomass fuel, the chemical energy inside releases as a heat. See, we will use the wood when we are here going for here means boiling the water. We will use the wood. We are burning the wood. When we are burning the wood, we are getting the heat, nothing but energy, heat energy. Okay, so that is utilization of the one of the biomass energy, that is we are burning the wood. So the chemical energy in the wood inside that is releasing as a heat. So it can also be used to produce steam, which can further be used to generate electricity. So that when we are burning the wood, that heat produced, that we can use to produce the we can collect the steam. Okay, when we are boiling the water, we can collect the steam and we can generate the electricity. So here the biomass, here energy. Another example, we can take waste. Waste we can collect, or we can use that waste, and we can turn into producing electrical energy. So manure and dung are fed into the biogas plant. So one example we are taking here, biogas plant. Biogas plant. So we are taking manure and cow dung we are taking and fed into the biogas plant. We can see we are taking here, we are arranging here one chamber, one here container type, and we are taking cow dung or manure, and we can take here one large tank we are arranging, and we are taking here compost. Okay, what we are taking the manure in that, and we can take how the heat gas is producing here. So that gas we are using for cooking and lightening. So the waste compost, the manure we are collecting again. So that manure we are using as a fertilizer. So in the fermenter, here the heated to approximately 38 to 40 degrees centigrade. So in this tank, the temperature will be 38 to 40 degrees centigrade. 38 to 40 degrees centigrade. So the substrate is decomposed by microorganisms. What we are taking the manure or dung in the large tank, so that is decomposed by microorganisms in the absence of oxygen. In the absence of oxygen and light. So we will tell anaerobic digestion. Anaerobic digestion means, so the microorganisms decomposing the manure or cow dung in the absence of light, absence of oxygen. And the final product of this fermentation process is biogas. Final fermentation process of this, it is the biogas. Biogas means what? What is biogas composition? Methane. So this methane we are using for a heating purpose, and that gas we are using for a cooking purpose and lighting purpose. So this is the main ingredient we are getting from biogas plant. So from biogas plant, what is producing? Methane gas we are getting. That methane gas we are using for cooking and lightening purpose. So it may look like biomass helps in increasing global warming, but in fact it is in another way. Means uh, we think that when we are going for biomass energy, it leads to global warming. It leads to global warming because it releases CO2 gas. It releases CO2 gas, leads to the greenhouse effect. But when we go in another way around, means in another way, when we think, means how we have to plant, we have to go for planting a tree. When we go for planting a tree, we can avoid here CO2 emission. Means CO2, the plants in photosynthesis process, it will take CO2. So then there won't be any greenhouse gas, any increasing of global warming. So plants intake carbon dioxide and release oxygen in the air. So plants will take carbon dioxide and we will take oxygen. So when we are going for planting the trees, it will take the carbon dioxide and it will release the oxygen in the air. So when these plants decay, they are burnt and carbon dioxide is released into the atmosphere. So when we are burning the plant, means when we are burning the plant and producing the steam, means heat. By that heat, we are producing the steam and generating electricity. So what happens? More percentage of the carbon dioxide will be increasing in the environment. So here what we have to do to avoid this, we have to go for planting a trees. So when these crops are again replanted, the new plants use the same CO2 and which was produced by the burnt plants, and this way biomass does not contribute to global warming. So due to this biomass energy, so no need to think, no need to worry that due to this there will be increase in global warming, because as we are burning the plants, as the decay of the process of the plant is taking place, increasing of the CO2 is occurring in the atmosphere. So to avoid this, again we have to go for replanting. We have to go for planting a trees. So if the plants are not replanted, then biomass may release carbon dioxide, which will in turn increase the global warming. So that cause is there, that effect is there due to the biomass energy. So we can avoid that. We have to go for replanting a trees. So energy from the sun is transferred and stored in the plants in the form of chemical energy. When the plants are cut or die, or wood chips, straw and other plant matter are delivered to the biogas plant. So when the biomass is burnt, it releases energy in the form of the heat. If you happen to have a fireplace in your home, then you are already taking part in the utilization of biomass, because the burning wood is a form of biomass energy. So the biomass plants burn wood or other forms of waste to generate steam. So the energy from the steam is directed via pipes to turn the turbines. So the steam rises up to turn the turbines, so that eventually that produce electricity or generate heat for homes and industries. So by using biomass, we can produce electrical energy. So we can see here working of biomass plant. So we are taking here fuel. We are burning the plant or any wood and producing a steam. So we are utilizing that heat to boil the water. We are producing a steam. So that steam we are passing into the turbines, where movement of the turbine will be taking place. Steam turns the blades of the huge turbines, and we are arranging the generator, which spins the generators to create electricity, producing electricity, and we are taking transformer. So a transformer increases the voltage to send electricity. So here we are using transformer. Then we are going for distribution. So distribution lines, then local transformers that will reduce the voltage, and that we can use. So we are utilizing for our for domestic purpose. We are using that electricity. So in this way we can utilize biomass. So nothing but what is biomass means, we are taking the plants and the organic material, means animals decay, and we can take the waste food we can take, and we can burn that where the heat is produced. That heat we can use, and we can boil the water where the steam is produced. That steam we can use, and we can turn the turbine blades, and where mechanical energy converts into electrical energy in generator. So that electrical energy we can utilize. So next, last one is tidal energy. Tidal energy is a form of hydropower that works by harnessing the kinetic energy created from the rise and fall of the ocean tides and currents, also called tidal flows, and turns it into usable electricity. See, when we go near the river or near the sea, on the top of the water, so we'll get the rise and fall of the ocean tides. So it will rise and it will fall. The tides, it will rise and it will fall. So by using that, tides, we can produce electricity. We can turn into electricity. So tides fluctuate to the gravitational pull of the sun and moon. How these tides means when we go near the sea, we can see, the rise and fall of the ocean tides. So how these tides are fluctuating means, so this is due to the gravitational pull of the sun and moon. So working of tidal energy power plant. So we can see in the diagram, the tidal barrage or tidal dam constructed near the sea, and here water we are collecting, and water is flowing. Here we can see here the water is flowing to the turbine blades. So where we arranged here near the sea reservoir, dam is constructed. So through that we are passing the water into the turbines. So during high tide, when the level of the water in the sea is high, so means from this level to this level we got water. So during the high tide, when the level of the water in the sea is high, sea water flows into the reservoir. We can observe in the diagram, the sea water is flowing into the reservoir of the barrage and turn the turbines. We arrange turbine blades here. So the water that is flowing from the sea, it is flowing into the reservoir where we arranged turbine blades, and here we can observe movement of the turbine blades. So the turbines, then it is turning the generator shaft and produces electricity. So here we can see, in this diagram also we can see the tide is coming in, where movement of turbine blade and producing electricity. And after that, here we can see in this diagram, the tide is going out. When it is coming in, then also the turbine blade is moving and we can produce electrical energy. And when the tide is going out also, the turbine blade is moving and we can generate electricity. So this tidal electricity generation works as the tide comes in, and again when it goes out, the turbines are driven by the power of the sea in both the directions. So when the tide is coming in, we can generate electrical energy. When the tide is going out also, we can generate the electrical energy. So during low tide, the sea water stored in the barrage reservoir is allowed to flow out in the sea. Again, we can see in the picture. So in the low tide, the sea water that is stored in the barrage reservoir, so that is allowed to flow out into the sea. Again, we are passing into the sea, flow out into the sea. So this flowing water also turns the turbines and generate electricity. So when water is coming out and during high tide, so we can generate electricity. When water is going out from that reservoir into the sea, again we can turn the turbine blades and we can generate the electricity. So as the sea water flows in and out of the tidal barrage, we can see the tidal barrage during high and low tide, the turbines rotate continuously and that will generate electricity. Continuously it will rotate to generate electricity. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.